welcome back to Resurrect. Now, nothing is worse than taking your car down to the alignment shop and paying them $100 for them to line up your car, just for them to tell you that something is bent, they couldn't quite do the alignment right, and now you've got to go figure out what's going on with your car, take it to another mechanic, just to get that fixed and go back and pay another $100 to get your car lined up again. So today, hopefully we can give you guys some tips and tricks to try to avoid that situation in the future. Behind me here, we have a 2009 C63 AMG that happened exactly as we just said. This thing was down at the Mercedes dealership getting alignment. Let me tell you, the Mercedes dealer is more than $100 to align up this car, or to align this car. So that's kind of a disappointment, but this car did not line up right due to previous accident damage, and something is definitely bent. So we're going to do some diagnostics on this in the garage to try to see what's going on and see if we cannot correct this issue. Now, there's a lot of guys out there that will say, to line up your car, this is all you would need. And I don't want to disappoint any of you, but this is not my bathing suit for this coming summer. This is a piece of string. And what you need to do with this string to get your car to line up right, they say, is to tie it to the exhaust or to the muffler. You can run it along the side of the car, and you can check your wheel alignment that way. And it is true that you can get a vehicle to drive straight using a piece of string, but that is only checking one metric of your alignment. It's not checking any of the other metrics, and it doesn't address issues of tire wear or perhaps handling issues that may arise in the future. So let's take a look at this vehicle, see what's going on here, and hopefully you guys can benefit from some of the information that will be discussed in this video.
After pulling the car in the garage, the first thing we're going to check is the camber while the car is on the ground and the wheels are in the normal position. I know from my alignment report which wheel is the culprit, but I want to confirm this with the camber gauge. Here I'm using a Longacre digital gauge, which is kind of like a hobbyist tool. Now, after getting the car in the air, we're going to lower the car onto a caster turning plate. These plates move in every single direction. They also have an indicator that helps you precisely measure the degree in which the wheel has turned. This is important because when you check the caster, you need to turn the wheel in both directions, either 15 or 20 degrees, depending on the vehicle you're working on or the equipment that you're using. So now we're doing the sweep by setting the gauge and turning the wheel by hand. The wheel is pretty easy to turn on these plates. We're turning 15 degrees to the left and then 15 degrees to the right as specified by the tool manufacturer. This tool's caster measurement is kind of finicky, but it can point you in the right direction as to where your problem wheel is. If you don't have any of these fancy hobbyist tools, there are some basic tools you can use to diagnose alignment issues, one of which is a regular 24-inch level. Assuming that one of your wheels is in the right position and the other is in the wrong position, the level can come in handy by providing you a measure of comparison. I have taken a dry erase marker and marked the exact position of where the bubble fell on the good wheel, and I'm going to compare that to the other side. When doing this, make sure to rest the same side of the level used on the driver wheel as you do on the passenger. After checking the bubble on my level, it is falling at different locations for either side of the wheel, which indicates there is a problem. Caster has to do with the angle in which the wheel leans in the same manner as I'm illustrating here with this steel wheel, but it's measured with a 15 or 20 degree sweep while turning the steering wheel. If you don't have a caster gauge, you could still take some measurements on either side of the wheel to see how the wheel sits in its normal straight position and compare it to the other side. Often on accident vehicles, you'll notice that the wheel will be positioned closer to the driver or passenger's compartment of the car due to an impact. Noting these measurements can help you diagnose bent suspension components. My least favorite part about using a string to check your alignment is the time it takes to untangle. But to check toe, you can use something like this construction string. By tying it to one of the exhaust pipes, we can run the string down the side of the car along the center line of the wheels. Of course, before we make any adjustments to the toe, you'd want to make sure that your steering wheel is pointed perfectly straight. Now we check toe by using the rear wheel as a guide and pulling the string perfectly straight. We can check the gap between the front of the front wheel and the back of the front wheel. If the distances are not equal when the string is pulled straight, you will have to loosen the nut on your tie rod and either lengthen or shorten the tie rod by spinning it. When these gaps are equal, your toe is at zero, and some cars will drive straight with zero toe. With the string method, you can most likely get any car to drive straight, but the string has, however, some limitations. It won't address issues of tire wear due to camber or caster issues. It won't help you if your car needs negative toe, which means the wheels are turned slightly inward. Many rear-wheel drive cars run a negative toe because under the force of acceleration from the back wheels, the front wheels will have a tendency to spread apart, so the string method is kind of limited in its use, unless you have some type of magical string, which I don't know about, but then you're really wasting good use of magic string on just doing alignments. That would be sad. In this clip, we're using a tool called TrackAce to check the degree of toe. This is basically a laser with a measuring stick on it, and on the other side we have a straight bar with a mirror resting on the other wheel. The laser reflects on the mirror back to the ruler that is stuck to the laser section. By doing this, you have a way to measure the degree of toe and dial it in negative or positive. As you spin the tie rod, you'll actually see the laser move positions. It's fairly accurate, probably not as accurate as the alignment machine at your local tire shop, but way more accurate than magical string and line of sight. After doing these checks, I decided to check the overall geometry of the frame with my frame measuring system. You don't need a frame measuring system to perform these checks, but you would need published dimensions of your car, which can typically be found on the manufacturer's Tech Info website, which would cost you a small fee. If you need to find this site, just Google the manufacturer's name and type the expression Tech Info afterwards, and usually the correct site will appear first. With these dimensions, you can cross-measure with a measuring tape or a tram gauge, but of course the car would need to be in the air. After checking the suggested measuring points with the measuring system, I determined that there was no issues with the frame. Everything was within 1 or 2 millimeters spec. So now we need to take the wheels off and get a good look at the suspension and steering components with a visual inspection. From under the car, we need to pay special attention to the control arms. If these two lower control arms were bent forward or backwards, this would mess with the caster and camber. Also, we need to examine the condition of the steering knuckle and hub assembly, the steering tie rod, as well as the suspension strut. All of these components are responsible for holding the wheel in the proper position. If anything looks bent or visibly damaged, those parts should be replaced, especially if they are on the wheel in which your diagnostics indicated that there was a problem. If you rebuild a car that was wrecked and the wheel is pushed too far to one side, it is best to replace all of the components on that side and possibly the subframe if it is possible and cost effective, because most likely you will have an alignment issue in the end. Now the next thing we need to do is look at the subframe. Looking at this subframe, it's hard to tell in the video, but one of my control arm mounting pockets looks slightly bent and the mounting hole looks like it could be damaged, so we're going to have to fit a new subframe on this car. Now we need to start removing this subframe by disconnecting all of the control arms from the subframe side only, and we also want to loosen and lower the steering rat, but we can leave it attached to the tie rods to save time. We also need to remove the motor mounts on this particular car and any hoses and wires attached to the subframe. Now we're going to attach an engine support strut on top of the engine. The aprons on this car are kind of short, so we need to attach the shop crane to the front of the engine so that the engine doesn't come crashing down when we remove the subframe bolts. The crane probably would have been enough, but I always like an extra level of protection when I'm working under a loose engine. It helps to have a hand when doing this, but often I work on my own, so I'm going to put this bungee under the subframe so it doesn't come crashing down after I loosen all the bolts. So we have a Mercedes subframe in front of us. This one is identical to the subframe that was on this car, but I lost the original video and I've since scrapped the original subframe. This subframe is way more damaged than the one that was on this car, as you can tell. But my subframe was missing teeth in the same area that this subframe is missing teeth. Without these teeth, the control arm bolts will not sit in the proper location and will move back and forth, and the camber will be off. In Mercedes-Benz world, new cars come with regular round bolts, but at the dealer, they do sell camber bolts, or crash bolts as they are known sometimes, and that will get you adjustability in the camber. But if these teeth are damaged, the camber bolt will not work properly. The problem I had on this car was due to a combination of worn out bolt holes in addition to a bent control arm pocket like this one, but not as extreme. Sometimes a bent control arm pocket is difficult to spot, but as you could tell by using this piece of wood to illustrate, if my pocket was bent just a little bit, a degree or so, it would cause my control arm to be really far out at the end of the control arm. Also, sometimes the subframe can actually shift on the mounting points. On this particular Mercedes, it's kind of difficult for that to happen because the bolts fit very snugly in the holes, and there are divot points that the frame must line up to on the subframe to mount. But on some other cars, the holes are much bigger, and there's actually a procedure for aligning the subframe with special tools that only the dealer might have. In these cars, a subframe could shift in such a way that it would throw your camber way off. One side would be too negative and the other side too positive. Here is an example of a camber bolt. Unfortunately, I don't have a Mercedes camber bolt. I believe this is a bolt from an American car, but the principle is the same on all camber bolts. This bolt has a flat spot on it or some type of groove, and depending on how the bolt is rotated, it will push the control arms in or out, therefore changing the length of the control arm and therefore the camber of that wheel. This bolt is more of a variable pitch camber adjustment, while the Mercedes-Benz camber bolts are more of a two-position bolt, so you can either add or subtract some camber. Usually adjustability is limited here to no more than a degree or so. Depending on how far off your alignment is, camber bolts may or may not help you. So here I'm using some RV support stands to suspend the new subframe. I like using these stands because I can lower the car on the lift onto the subframe, but I can use these lifts to adjust the subframe just a little bit so it will line up right. None of this would be needed if I had a second hand, but it's just awkward to hold the frame up while getting the bolts in.
Alright guys, so for this video we're pretty much wrapped up, and let me tell you, I did get the alignment done at Mercedes-Benz, and afterward everything is perfect. Everything lined up. The camber and the caster were pretty much spot on. My caster was about 1/10 of a degree off. However, the techs at Mercedes-Benz said that they see this often in cars that have never been in an accident, so for them it wasn't that far off to be concerned about. But so in my experience over the years of rebuilding cars, in summary I'm going to show you what to look out for. But first off, control arms. This is the weakest link in your suspension. It's the part that's easiest to bend. So this is something that happens in a lot of cases where that wheel has taken a hit. Your control arms will be bent, and sometimes it's really easy to spot in a control arm like this that's straight, but in a control arm has like kind of a natural bend to it, it can be harder to spot. So watch out for that. Also, control arms are pretty inexpensive, so it's a good place to start. And also watch out for these rubber bushings. You know, if you see them kind of stressed or bent, that could indicate there's a problem with the control arm, or it could indicate that there's a problem with the subframe fighting against the actual position where it should be in. So watch out for control arms. This is probably the second most common issue that I've seen with accident vehicles is the strut. And a strut can have a very slight bend to it. It could be this way or that way, in any direction. It could throw your alignment out, and it's very difficult to see. So that's your next possibility. Even these strut tops, sometimes they can shift just a little bit. So watch out for bent struts. That's very common. I found this just about on every situation where the wheel was bent. I had to replace the strut. And as I said earlier, guys, a lot of times it's better if you know one wheel was whacked pretty good. It's better just to replace all the parts than to just start chasing problems later and then find out your alignment's out. So if the parts are not that expensive, just replace all the parts on that side. And as we mentioned in this video, your subframe. Yeah, normally subframes, in my experience, and in manageable accident damage, usually the subframe doesn't cave in and bend radically. These are pretty strong, guys. Aluminum ones sometimes will crack, but this is a steel one. So normally you're not going to see any mega signs of bending, but as we stated earlier, in this particular style of subframe, these pockets where the control arms slide into, if they bend just a little bit one way or the other, it might be hard to see. And a little bend here doesn't look like much, but when you get out here where the control arm ends, that can change quite a bit. It could be a centimeter or two. That could really throw your alignment out. And as we said earlier too, watch out for the mounting holes for the control arms. If these holes are worn out and these actual bits right here, these little teeth are worn out. Now this is just for Mercedes-Benz, but you know, if you see other type of wear, then that could be throwing out your caster as well. And then subframe shifts. I've seen that a few times. Now not all cars are so easy to shift the subframe, but I have worked on, for example, Audis.
where the subframe can shift and is lineable, and there actually is a procedure for lining up the subframe. So watch out for that sometimes, but you'll see signs of that on the actual frame. You'll see, or on the bolt, you'll see it kind of have shifted, and so you might see signs of it moving around. So that's the next thing to watch out for. And lastly, your steering knuckle. Now, very rarely have I seen issues with these. This is usually a pretty stout part. It's pretty strong. It's hard for this to bend because these parts are so short, but I have seen it before, so watch out for your steering knuckle or the rear knuckle as well. I mean, those things can bend and completely throw your alignment out. So those are probably the most common things I've seen. And yes, your frame could be bent, so check out for that. Normally frame damage, you can kind of spot that in the frame rail, a kink or a bulge or something like that, so watch out for that. Or your strut top mounts, you might see deformation on the top of the metal, or maybe the holes might be worn out, so look out for stuff like that. But that pretty much sums up most of your most likely culprit in a salvage car. So guys, thank you so much for watching. I really appreciate it. Please comment, like, and subscribe if you enjoyed this video. And also follow me on Instagram under Resurrect, the same name as the channel. I really appreciate you guys watching, and we'll see you next time.